Looking at Green's theorem. This is a key theory in vector analysis or differential geometry. So if you have not subscribed to this channel, kindly start by hitting the subscription button and also the bell for any notifications. Share also with your friends so that every time I post a new thing here, you're the first one to get the tutorial. Green's theorem is actually one of the application of double integral and line integrals. So let us consider this kind of a question here, whereby you are told that to solve this region divided by this. So in this case, you are told to sketch the region. Secondly, you are told to state the order of integration. And thirdly, you are told to evaluate the equation. So you must be able to see how this kind of region for the application or for the calculation will look like. The integral can be evaluated as both line integral around a region of R or by using Green's theorem. So there are two ways of solving this kind of a problem. You can use the integral, line integral, or you can use the Green's theorem. Now, having noted that, we'll now need to know the definition of what Green's theorem is. So the Green's theorem in our plane states that the counterclockwise circulation of a vector field around a single closed curve is double integral of the curve of the field of a region enclosed by the curve. We are saying Green's theorem means that the outward flanks of the field, say this field, across a simple closed curve C is equal or is same as double integral of divergence of f of the region R enclosed by C. That is this one, which can be expanded to in this using the given field, as we have just stated, is same as this one. Is same as this. Is same as the double integral of the divergence. Remember, the divergence of f. The divergence of f can be expressed in this form. This is simply the divergence of m. This one. Divergence of m. What we are calling is known as divergence integral. So Green's simply links this relationship, gives you this relationship in our knowledge. So that if we are talking about our equation that we just looked at, considered, if you were to sketch this, then you will have this is y, this is x, and we'll have y being equal to x. So that means is this line. This is y being equal to x. Okay, then we have y being equal to root x. Y being equal to root x. Y being equal to root x is simply a curve through the origin. To curve this through a given point. So this is y equal to root x. So that means Then we have x from 0 to 1, so this is actually 1. So this is where we have x being equal to 1. So that basically means, the curve under the definition for this, the region that we need to calculate its area is actually this one. It's actually that one, between those ranges. Because when x is 0, y is 0, and when x is 1, y is 1. So here is the peak of 1. So that's the region. Remember, we have said there's two ways of solving this problem. We can use the line integral, or we can use the Green's theorem. But as for our interest here, we want to practice on how we can solve this using the Green's theorem, because we want to see the relationship between the Dumbo integral and the line integral. Because remember, we are saying that the H1 flux of a field, given field here, across a simple closed curve C, and is that one, you can see the curve C here, is equal to the double integral of the divergence of f of the field given. So a field given here is xy squared xy squared. So if we want to solve this now using our knowledge, as we know, our equation here is basically xy squared is xy squared. So what we are having here, we have xy squared, and it's double integral, so we can just solve it directly. So if you solve this, we evaluate this. B was state the order of integration. That means we have, just writing it down, x from 0 to 1, then y equal to x to y equal to root x. So you will need to rearrange this one so that the y's dy comes first. So this will be y squared x dy dx. Okay, so you can see here the first evaluation will be in respect to y. So that if we do that one in respect to y, we do this one in respect to y, we are having in respect to y, integrate this one in respect to y, we having now what we are having is now from 0 to 1 for x. Now integrate this in respect to y, we'll have 1 that k of xy cubed over xy cubed, and this is learning from x to root x which if we substitute, remember this is still under dx. If you substitute this, we are having root which is x power. We are having x by x squared cubed of course over 3, take away x times x power, it's x, yeah, y equal to x cubed over 3. Of course, all these will be now done from 0 to 1 dx. So what are we getting in this? We are getting x. This is power half, remember, because it's square root. Power half, and this is power half still. Power half. No, this is not power half, is cubed and change because it's x, the other one is the root x. So if you do this, is 3 over 2. Okay, so we are having we are having 5 over 2. That's 1. So what we are having 3 over 2, and we are adding this to power 1, which is equal to 2 over 2, which is 5 over 2. 5 over 2, so we are having x to the 5 over 2 still over 3, take away 4, x power 4 over 3. So this is basically 1 over 3 into x power 5 over 2, 5 over 2. Okay, take away x power 4. I think that's what we end. Yes, that's what we end. All these from 0, 1 to the x. So if we factor out this, we can have 1 over 3 outside there, so that this is 7 over 2. That becomes 2 over 7. 7 over 2. So this becomes 2 over 7. Okay, 2 over 7x, 7 over 2. Take away, and this one becomes 5x power 5. Power 5. Oh, this is from 0 to 1. 0 to 1. So if you substitute this one 0 to 1, 0 to 1, see that this is 1 over 3. 1, 2 over 7. Take away 5. And the other one is take away, that is 0, 1, 2 over 7. Take away 5. Oh, so this becomes 0, of course, tends to 0. So this is basically 2 minus that 5. So this is actually leading us to from evaluation. You see, you are having 1 over 3, 5. So this is the unit for that, and we have done that by double integral. So closely we can see that. So if that's the relationship that you want to do, remember, if you have a question on either of the calculations here, you can leave a comment. If you have also a question that you need us to tackle, you can leave it like a comment and be able to look at it. If you also have a question on another field that you need clarification, I can also tackle that. Remember to subscribe so that every time I post anything here, you will be able to get the notification. Now, you want us to look at something here on extension of that, and is that this kind of question. So we are told we use Green's. Green's theorem to evaluate this integral x y dy minus y squared dx. Now where c is a square, and cut from first quadrant of the line x equal to 1 and y is equal to 1. So the sketch of this is basically this x equal to 1, 0 there. So y being equal to 1, okay, x is equal to 1, so like that. So this is the area that you want to work on it at the sketch. So having identified that, and we remember what Green's theorem states, we will need now to work out for this integral in the region being partial derivative of n over in respect to x, or what we are calling divergence, m over dy. What we are saying, this we have said is same as the closed region of x, y, dy minus y squared dx. So if you know this, then it will mean that we can get the partial derivative. We can get from here relationship. You can see our m here is actually y squared, negative y squared dx, and we can see that our n here is like is actually xy. So that if we integrate this, we can see that we are getting the double integral, and these are coming from our sketch. You can see y and x, the upper limit is 1, and then if we integrate this divergence, this will give you 3y dx dy. So remember, if you have a challenge arrive to this, just leave a comment. I'll be able to look it and check it. So what we're having here now, we're having that, and then if we work at this using now the idea of integral. So first, in respect to dx, that 3xy, so that's we'll have 0 1 3xy. Okay, then in d, this from 0 to 1 dy. Okay, so that this one gives you 1, so that's 3y. Integrating 3y in respect, you'll get 3 over 2 y squared. Then from 0 to 1, you can see clearly the answer will become 3 over 2. 3 over 2. So if you have any question on this, kindly just leave a comment, and I'll be doing more of this in the next tutorials. So that is on how we apply Green's theorem. And remember what we have said about how Green's theorem stands for, and it basically involves through this relationship. That relationship. Having done that, remember to subscribe and also share with your friends, and always check on what we have posted here. If you have a question, don't strain so much, leave it down there in the comment space, and you'll be able to check it out, and that is